Hi, everyone. Hope you're doing well. Today we'll cover Chapter 13, starting into the design and prototyping section of the class. So let me pull up the slides. Looks good. All right. So like I said, the next few chapters are really going to be taking a look at how companies start to actually design and develop products. So now we're kind of past the planning stage, and now we're kind of going towards like the action stage of actually developing something, putting it out into the market, commercializing, et cetera, et cetera. So the first part of this is design, designing the actual product. So what is design? It's a synthesis of technology and human needs into manufacturable products. So it covers a kind of a wide range. It can be the style, it can be ergonomics, which I'll cover what that is. But the idea is that it really should be much more encompassing than just making something look better. So a good quote from an executive at Herman Miller, high-end furniture company. His statement was, "Beautiful is not enough. The product must be useful. Design includes the whole human interface." And I think this chapter tries to cover what that means in a little bit more detail. So if you think of Apple, you think of, well, what is it about their products that make them popular? The truth is, it's not necessarily that they're more technologically advanced or they're more capable than competitors. They're really not. A lot of what makes them popular is their design. They're very effective designs. They're easy to use. They're intuitive. And actually, they weren't really the first ones to do this. They took the sort of clean, simple appearance that we're used to today. They took that from 60s record players and radios that were created from a company called Braun. So you can see a picture of what that looked like. And, this is a product, a radio that was, at this point, 60 years old. But you can sort of see how there's some elements of this that look a little bit like some Apple products, and you can sort of see, okay, that they sort of modernize that design in order to make it something that's useful for everyone. So innovations can come in a few different forms. I mean, I think we've talked about this, how innovations can be incremental, they can be radical, they can be disruptive. One sort of idea along the spectrum is design-driven innovations. The idea behind these is that they aim to actually create new markets. So they aim to create new meanings. And what they're trying to do here is that the design itself has a leadership role, unlike, say, something, generally we talk about market-driven innovation, which is, find out what the customer wants and then try to make something for them. With design-driven innovation, you're sort of saying the design and style of the product is really going to be what drives the market. So it's sort of a different sort of mindset for product development. All right, so where can design help? Well, if you have a very efficient design, it can help for speed to the market, which means you go from concept to actually commercializing much more quickly. Can make it more easy to manufacture. It can meet customer needs more easily. And there's this concept of universal design that I'll get into in a little bit, but essentially the idea of designing products so that they can be used by anyone easily. Design can be used for differentiation. Kind of going hand in hand with this is the idea of supporting corporate identity. So you think of major brands, Googles and BMWs of the world. Their designs are really meant to help them stand out compared to competitors. And design can be helpful for the environment, actually. So design for disassembly is the idea that you're going to use as many elements, as many raw materials as you can that can be separated and recycled. So metal, glass, things like that can be easily disassembled and reused for other products. Now, I mentioned that we talk about universal design. The idea behind universal design is that you're making something that anyone can use relatively easily. Okay, so what's that mean? You want equitable use. So it's useful for people with varied abilities, flexibility in use, so wide variety of preferences, and it's simple and intuitive to use. regardless of, if you're, 10 or if you're 60. Perceptible information. So think of like how some products might be color coded in ways that are, sort of intuitive. Green means a positive, red means a negative. Things like that. That's sort of be perceptible information. Tolerance for error. The product doesn't break when you make a mistake. Low physical effort. So you can use the product without making yourself tired. And size and space for approach and use. So the product is easy to use, easy to manipulate and to work with, and it doesn't take up too much space. So, by the way, so I'll quickly mention these. I've got 7 bullet points here for universal design. You don't necessarily have to have all of these, but these are kind of the core concepts. If you want a product that's going to be universally designed, these are some of the ways that a company, some of the approaches a company can take to get closer to universal design. I mentioned a few slides ago ergonomics. So what is ergonomics? It is the study of human characteristics in order to develop appropriate designs. And this is really important for consumer products. So if you think of a toothbrush, for example, if you want a toothbrush to do an effective job, it needs to be something that can, reach to all parts of, a person's mouth, and it can actually do a good job of actually brushing even, to teeth that are tough to reach. So Oral-B makes toothbrushes. And one thing that they've done is that they've videotaped, well, a couple things actually. They've videotaped people using toothbrushes to take a look at, brushing patterns. And they've used robot arms to actually test out different prototypes. So they'll create a prototype of a toothbrush that they think they want to make. And they'll test it on a robot arm to see, okay, is this going to work? Is it not? And they can sort of see before they actually make millions of toothbrushes, is this design going to work for them? Or is it ergonomically maybe not so effective? They also have high-speed cameras that they use in order to make sure that the bristle configuration is most effective at cleaning teeth. So it really kind of captures all these little nuances. And hey, it's you're brushing your teeth. It's an everyday product, but it's also a really important product. And they want to make sure that whatever they come out with, that it's the most ergonomically sound toothbrush that they can make. So if you think about creating, last slide I had, an electric toothbrush. If you think about, okay, how do we make sure that that's going to all fit together, right? There's different parts to it, right? There's the head of the toothbrush, the bristles, there's the batteries in the toothbrush. If it's an electric toothbrush, there's kind of the design where you can see there's, little grooves where you might, hold the toothbrush so it doesn't slip out of your hand. There's all these little things. Now, how do you make sure this all fits together in a way that, makes sense for, a human use? One way to kind of map this out is using product architecture. And the idea of this is it's just a 4-step process for product design. All right, so if we're using the electric toothbrush as an example, first you create a product schematic, right? You say, okay, these are the different parts that we need, the battery, the head, the bristles, etc. You cluster the elements together. You create a geometric layout. So in other words, you're literally doing like an architect would for a house. You're doing the same thing for a toothbrush. You're drawing it out. And then you want to check the interactions between the chunks, make sure that, where the battery is, it doesn't, interrupt where you're holding the toothbrush, and make sure that doesn't interrupt, the head of the toothbrush, et cetera, et cetera. Now, we talked a little bit about prototypes throughout the semester, and this is really the stage of the new product development cycle where you're focusing on prototypes. But there's a couple different versions you can have. I think when we've talked about prototypes, we've generally focused on comprehensive prototypes, which are they're complete, they're fully functioning, and they're ready to be used by customers. And we'll get into those a bit more in chapter 15. You can also have focus prototypes. So these are those that are not fully developed. They might have a limited number of features. So if you look at the picture I have here, you might sort of look at this and say, that looks a little familiar. The idea behind this is this would be a phone charger, or a focused prototype of a phone charger. It's wood, it's rope, but piece it all together, and it could look like a smartphone charger. So this is kind of what you're looking at with a focused prototype. It's sort of saying, well, it's not going to work, but it can give you an idea of what a finished product would look like. And again, really important for consumer products that everyday customers are going to be using. Now, you might start to look at some of this and say, all right, there's sort of a lot of pieces here, right? You've got to make sure that you have, all the input from customers that we've talked about in past chapters, which is going to come from marketing. You've got to have research and design people. You got to have engineering. How does this all fit together? Well, there's a couple of ways you can do this. One is co-location, which is really just putting important individuals and areas in close proximity to make sure that they have easy communication. Really important for, the prototyping and design stage. You could also do digital co-location through, your Zooms and WebEx and Skype and whatever, countless other Teams, countless other products that can help with co-location. Obviously, in our sort of, remote work, hybrid work sort of environment, digital co-location has become much more common. But as you can imagine, it does rely on a few different things to make sure that it fits together. If you have people, they're not working right next to each other physically, you need to have the right resources to make sure that digital co-location is working. One approach is having a producibility engineer. This is a third-party engineer who understands and can ensure that the production requirements are met by designers. So in other words, a producibility engineer might be someone who is kind of making sure that marketing and R&D and engineers are all working together and kind of keeps it all, in one, going in one direction. This is sort of a difficult thing to really comprehend until you have this sort of work environment where you've got these different groups of individuals and they have different goals, but you need a producibility engineer to make sure that, hey, at the end of the day, we're trying to make an electric toothbrush or whatever it is you're making. Another thing that can really help with this is any sort of computer-aided design. It can greatly accelerate the design step. We're talking about product architecture a couple slides ago. CAD programs or similar programs can really help out with this, because then you don't have to actually draw. You don't have to draw the electric toothbrush. You can instead just do it on a computer, and it can really help that product architecture process. And then, if you have this capability, you can move on to 3D printing. So you take whatever you've mapped out on your computer-aided design and put it through a 3D printer. You get a hard plastic version of the product, and it might be sort of a semi-functioning prototype, maybe a focused prototype, but it would really give you a good idea of like, all right, I think we're getting a little bit closer to, the finished product. So this is what you see with a lot of companies today, is that because 3D printing has made it so easy to rapidly prototype new products, you'll see, and we see this, by the way, I mentioned this, we've got our MTD2 and difference maker programs where a lot of companies are started from students. We've got 3D printers at the university, and they're really an effective way for young companies to test out new products to see, all right, is this the direction we want to go in, or do we need something that looks a little bit different? And as the name indicates, you can rapidly spit out a bunch of different prototypes in just a little bit of time. Okay, so that's it for chapter 13. If you do have any questions, please let me know. Thank you.